Dear students, good morning. Today we are going to see about the deep learning about the neural networks. Here we have the many types of neural networks. In that we are going to see the major four types that to feed forward neural networks. After that, convolutional neural networks CNN. Then the important one, the recurrent neural networks RNN and GAN, that is generative adversarial networks. So these are the thing we are going to see. What about the types of neural networks? Okay, so let us see one by one. The first one, feed forward neural network. So coming to the feed forward neural network, we have the three categories, that is architecture, training process and use cases. In the architecture we have the layers like input layer, hidden layer and output layer. And neurons, what is the purpose of neurons? Node within each layer that performs computations. Okay, so that is the purpose of neurons here in this architecture we mentioned. And director connections, information passes forward without cycles. So coming to the training process, how the training process takes place in this feed forward neural network: initialization and forward propagation, back propagation. So initialization, in this stage the weights are initially assigned random variables, it is assigned as a random variable. Forward propagation, inputs are processed layer by layer to generate output. Back propagation, errors are propagated backward to adjust weight. So this is how the training process is taken place. Coming to the use cases: classification, regression, clustering. Classification and this recognized pattern and categorized data. Regression, predicting continuous outcome. Clustering, it is grouping similar data points. So these are the use cases how to consider while doing in the feed forward neural network. Okay, and coming to the convolution neural networks, convolution neural network, it is grouped as a convolutional operation, pooling layers, application in image processing. So convolution operation, in this convolution operation we have the filters and stride and padding. Filters, it is a learnable kernels, we can call it as a learnable kernels applied to the input to extract features. Stride determines the amount of movement of the filter over the input. Padding, we all knew about exactly, that is adding zeros around the input to control the spatial size of the output, that is called padding. So this is how the convolution operation takes place. Coming to the very important stage, that is pooling layers. The pooling layers, here we can have the max and average pooling and reduced dimensionality. So coming to the max pooling, takes the maximum value from a region of the input. Average pooling takes the average value from a region of the input. Reduced dimensionality helps in lowering the computational load. And the third thing, it is an application in image processing, how the CNN is used in the especially the image processing application. Image classification, identifying the class of an image. Object detection, locating object within an image. Image segmentation, partitioning an image into a meaningful segment. So this is how the CNN is very much useful in the image processing applications, as we already discussed in terms of application. Image and video processing, it is used in day-to-day life, is very much needed. Next, coming to the RNN, that is recurrent neural network. In recurrent neural network we have the three stages, that is loop mechanism, long short term memory, and where it is used application in sequence data. So coming to the loop mechanism, sequential data designed to handle data sequences. And hidden states maintains information of previous inputs. This is used for maintaining the information of the previous inputs. Feedback loops, connection that cycle through the network. And long short term memory cell store information for long periods. Gates, for what purpose we are using gates here? Control the flow of information, input, output and gates. Okay, and avoid vanishing gradient problem, effective in learning long term dependencies. Applications in data sequence: language modeling, predicting the next word in a sequence. Time series forecasting, predicting future values based on past data. Speech recognition, converting spoken language it is into text. This doing a vital role in nowadays in chatbot applications. This is how the recurrent neural network is to be. And coming to the generative adversarial networks, that is GAN, we have the three categories again here: generator and discriminator, training dynamics, and application. Okay, and here the generator and discriminator, generator create fake data similar to a real data, and discriminator, what it does do, differentiates between real and fake data. And adversarial training, both network compete and improve the through training. And coming to the training dynamics, loss function used to measure the performance of the generator and discriminator, and iterative process that we all knew that is the repeated process to obtain the expected outcome. Okay, both network can turn in a training until equilibrium is reached. Convergence challenges balancing the training of both network to avoid failures. And coming to the application in data synthesis, image generate creating new images from learned patterns, text to image synthesis, generating images from textual descriptions, data augmentations, enhancing training data set with that is where with synthetic examples. So this is how this GAN is. So still now we have discussed about types of neural networks, that is feed forward neural networks, what about the mechanism, and conventional neural networks, recurrent neural networks, and generative adversarial neural networks, GAN. Thank you for your passion listening.